Well, to get started, I just want to give a little bit of a description about myself. So currently, I'm basically the lead software architect for a group at UCLA that essentially works on, consider it prototype oriented stuff. Can range anywhere from a network protocol all the way up to a front-end framework. So day to day we do all sorts of different stuff, but it gives me good exposure to a lot of different technologies, a lot of different frameworks, and I'm of the camp that I love a lot of things. So all just tools in the toolbox. I'm also an independent consultant. I'm running my own firm since I was 14, so it's been a few years now. And formerly, I was the chief technologist at a startup that was basically building core technologies for developers in kind of a distributed model of consulting. Now, what I like is pretty much anything from layer 3 up. So I happen to be a big fan of network and routing protocols, written things like a UAV routing protocol for fluid sparse networks. I happen to also like doing infrastructure as code. I'm a big fan of Chef, do some Puppet as well. I love frameworks and APIs, doesn't matter the language, doesn't matter be it JavaScript, Ruby, PHP, .NET, love them all. Web applications, and of course front-end toolkits as well. So really, what it comes down to, I enjoy building internal tools that work. So tonight, I'd like to talk a little bit about frameworks. What is a framework? Kind of a general question. According to dictionary.com, it's simply a skeletal structure designed to support or enclose something, which tells us nothing. Or a frame or structure composed of parts fitted and joined together. Tells us a little bit more. Maybe doesn't offer us guidance as to how it's fitted together, but it's just kind of a general definition. Software framework on Wikipedia, a little bit better. A software framework is an abstraction in which software providing generic functionality can be selectively changed by additional user-written code, thus providing application-specific software. Again, though, pretty generic. Do I open up an existing file and make some tweaks here and there? Can I just extend seamlessly? Doesn't really give us too much guidance. And because it doesn't give us too much guidance, because there's no one definition of frameworks, we have some other things that we often get stuck with frameworks. One of them is that they black box their internals with complexity. Many people here probably hate frameworks because you can't just open it up and see what it's really doing. You have no way to understand all the internal workings of it. And they also define a right way of doing things. They tell you how you need to code. They give you the objects that they say you need to use. And it really is their way or no way. If it's an MVC framework, it says use MVC. If it's, and you don't get much option. But a well-written framework, you should be able to drop the MVC and still be able to use everything else. And thus I would pose the question of, is it really the right way to black box internals and to define a right way of doing things? Or should we be approaching this topic a little bit differently? So I'd like to start off with a little bit of a case study. A few years ago, I and a couple other people, we started to try to put together what one would call a federated consulting firm. The idea of a federated consulting firm was that the company itself would provide tools and business processes core, kind of giving the benefits of bigness that you would see in a large consulting firm. But that all the consultants would operate independently. So they would use these core tools, they would use these core processes, it would speed up their development, it would let them just be developers. And so that was the concept, and so we needed a stack. And we needed a stack whereby we had a core framework that established a baseline. If we lost a consultant at some point, we needed to be able to bring somebody else in, and they needed to be able to step right in and understand what was going on. We also needed to support a slew of plug-and-play modules. We didn't want, if you're going to build a core set of tools, well, you better be able to plug and play so you can drop in the features you need so you're not re-engineering them over and over again. And so we set out and we said, let's build our proprietary edge, right? Kind of something that a lot of people start out with. They go, awesome, we're going to go reinvent everything. So we started with a little execution manager, a little object container. Then we had maybe like 20 different base structures that define kind of all the different types of kind of general objects, data structures, stuff like that you might expect. Then we went ahead and wrote a whole bunch of libraries that did all these kind of useful things, and here were a few of them, and there are about 40 more. And then we said we need to model everything, so we sat down and we wrote up a whole bunch of models. And this is starting to feel pretty familiar. A lot of frameworks do exactly this. They've got a whole bunch of objects, and it starts getting pretty rich. And we said, we wanted to have everything organized well, so we put it all in namespaces, which also sounded good, but really quickly got really confusing. And then we needed a way to manage those modules, those plug-and-play pieces. So we set out, we wrote some module management code. And then we went out and we wrote a slew of modules, which define their own objects, their own models. And then we added a little feature that would allow them to override anything they wanted at the application level. Not just in the case of load this file or load that file, but literally the case of load this other class and still inherit from that modules class. And so it started getting pretty complex. And our first problem was we'd reinvented the wheel, right? I was talking here about a whole bunch of models and libraries and stuff like that you see in every framework. You see templates, you see MVCs, you see active records. But the problem is there was no framework out there that did everything we wanted. So we didn't have a choice. We said we can't pick and choose, we must write our own. And in reality, I mean, you couldn't really sit there and rip apart at the time something like CodeIgniter. You couldn't just take one piece and rip it out. Problem two was complexity. The structure of our core was pretty complex. There was object inheritance everywhere. You had many, many layers deep of code. When you added in the modules, it got exponential the entire system. And well, when you started loading 4 or 5 or 6 modules, you were having a hard time figuring out what was actually overriding what. And then application level overriding just completely rewrote the playbook. And so there was no good way to keep track of it all. And of course that leads us to a third problem, which was the learning curve. We had over 100 pages of documentation in about size 9 font. And that was just for the core and some of the baseline modules. You had to know the system inside and out to use it. You had to read that documentation to understand what was going on. We had a very logical system. We covered a lot of use cases. You could plug in and do your benchmarking or your whatever you wanted to do. Unfortunately, it was very complex and it took a lot of time to learn. And it was not conducive to our business model. Our business model said we were supposed to simplify the lives of a consultant. We were supposed to let them develop. And what we had done instead with the framework here was we had made their life more complex. They might not have to handle billing anymore. They might not have to write an active record model. But they sure as hell had to spend a lot of time learning how to use what we had done. And of course, the fourth problem, kind of more of a, I guess, kind of just a conceptual one. This is not PHP. PHP is defined as a widely used general purpose scripting language. What I'm talking about is not that. What I'm talking about in many ways is Cocoa.NET or the Java library. I'm talking about something with a tremendous number of objects and everything's extending something else, you're loading in modules and all of that. This is not actually what PHP is. PHP is lighter weight. And so while I would say that the example I'm presented so far with this case study is maybe an edge case, this is a systemic problem. Most of the frameworks out there today, and certainly the ones that were out there when we had started with this initial approach, most of them approach it this way. They approach it on the all or nothing approach. They don't say pick and choose one little bit here or there. They kind of define the world in which you're going to work, and that's the way you're supposed to work. They tell you how to do your job. And so then I pose the question, how can we do it differently? We want to give developers what they want when they want it, and stay out of their way otherwise. Kind of a lofty goal. I'm not really talking about how to do it yet, but we'll get there. And at our firm, when we took this approach, developers really did like it. They found this very, very useful. They were happy to work with this toolkit. They could use what they knew. They could learn more when they wanted to. It was almost an iterative design process. As they needed a new feature, they would go look and, oh wow, it happens to be there. But if they had their own way of doing it, they could still do that as well. And so we let them do it their way when they wanted to. So this presentation, I'm really going to talk a lot about ways we can give freedom back. So I'm going to dig into some of the internals as I do this. So a few of the topics that I'm going to talk about today, one will be taking advantage of PHP's Autoloader to actually implement truly seamless extensibility, the ability to override a class any number of times and still in your application layer, you just are referencing it by one name and you've dynamically stacked all these different classes along the way. I'm going to talk about plug-and-play execution stack, writing an execution stack that literally says nothing more than this event is firing, that event is firing. Everything plugs into it, handles your entire execution with nothing more than events. Talk a little bit about MVC routing strategies. I'm not going to get too deep into routers themselves, but I'm going to talk about whether you should be using implicit or explicit or some sort of a hybrid approach to the way you handle your routes. Talk a little bit about output buffers. namely just kind of HTTP response buffering in general, and then also how you implement views and templates and stuff like that. And I'm going to close up with a little bit of talk on persistence layers. It'll be probably my lightest bit. It's a lot of code, but it's just kind of stuff we're going to move through quickly. Now, I've got a lot of code examples up here. I've got a lot of links in here. And so I wanted to go ahead and kind of just pull out the fact that this is all on GitHub, so you can just go to this if I'm moving too quickly. You don't want to stop me, which you're more than welcome to if you'd like, but otherwise, if I am moving too quickly, feel free to just pull this URL up. You can always go back and look at any of the slides. My examples today, many of them are sourced from Laravel, which is the framework that was talked about last time. I've also sourced some examples from some lightweight frameworks. Evander was a framework we churned out a while ago, just kind of an open source equivalent of what we did at our firm. Lightweight, maybe not as extensible as it could be. But then Evander 2 is something we're working on. It's not actually public, but what I did go ahead and do is I just deployed a few little small components that are like toys in a way, that are pieces of it, that I can use as examples here. And so the code for all of these, feel free to dig in and actually see them in motion. I forget who it was who said they were working on implementing an MVC, but you can find a really simple MVC implementation in the Evander dev repo, for example. So with that said, any kind of questions on kind of general stuff before I jump in, or shall we get moving? Okay, let's get started with autoloading.
I have a question.
Yes?
What's in the name Laravel?
Laravel? I don't know what it means. It's just no. Laravel is not a framework I wrote. Laravel is somebody else's framework. It's a great framework. I use it a lot, but it is just one I'm going to be using here for examples. The other two are things that I have written in one form or another. Okay. So autoloading. In the early days, we used include and require, and you could pull them in by individual files. You could pull in one file that had those individual lines in it. And then we got the autoload magic method, thanks to PHP 5, which also gave us a lot of other cool magic methods and other things like that. So the autoload method basically allowed us to say when a class is called that we don't know about, we take that class name and we can execute some code to figure out what to do. And so in this case, I just said basically, well, if I've got a class that gets passed here, just go ahead and that's going to be the file name that I want to load inside of the lib folder. So that's an autoloader. Very simple. And in PHP 5.1.2, they gave us basically what one would call an autoload stack. The ability to say, well, here's a function that you can call to try to autoload it. That doesn't work. Here's this other function, and to actually be able to do a whole stack of that stuff. So just kind of calling out some different basic approaches to autoloading. And then in PHP 5.3 with Anonymous, we could just stick the function directly in. Just kind of more eloquent, but not really any difference in functionality. Now, with all of that, we started seeing all these different ways in which people wanted to organize their classes, and all these different ways in which people wanted to load them. And what we eventually arrived at was PSR 0, which was basically about how you could namespace your classes and auto-load them in kind of a standardized way. And basically what it said is, first off, we have fully qualified namespaces. One where you have a vendor name being the first element of a namespace, followed by some number of namespace submodule type stuff. You could kind of pick and choose as you'd like, followed finally by a class name. And now, in terms of autoloading, what it did, it gave us 3 rules. It said that we'll take the slashes, wrong direction on the slash here, but the slash is converted to directory separator. It said the underscore is converted to directory separator, and it said the .php was appended after class name. So this would use that, based on PSR 0. So an implementation is actually provided as part of PSR 0. I'm not going to get into it, but that's basically the implementation. And we've got it to a point, but let's go ahead and give an example. So let's say we've got a session that was provided by this guy, some vendor. And he organized it reasonably well. He named that particular module session. He said, well, it's a model, so I should put it in a model namespace, and finally it's going to be called session itself. So we'll go ahead and we'll call that. And it's pretty hard to use because it's long. And so we get this use keyword instead. We can say, well, okay, fine. Let's go ahead and use some vendor session model as model. So now we've renamed the namespace, or not renamed it, but we've created an alias for it, a static alias, that allows us to, instead of saying some vendor session model session, we can just say model session. So it simplifies the syntax, makes things a little bit easier. let's say later on that I have I decide to extend this model with my own model. I can go in there and I can just replace that use some vendor session model with, say, my special application session model. So it's not, it's fairly easy to do, but we have a problem. Because when we add multiple vendors, we have to be more specific with use. So, for example, for the session, let's say I had a session model, but let's say I had this some vendor session with some models in it, but I also had some vendor, I don't know, cache with some models in it. I can't now say some vendor session model as model, because then I can't deal with the fact that I have some vendor cache model as well. So instead I have to get super specific, and in doing so I actually lose what it is I'm worried about here. So I don't now know if I say session equals new session with the alias I've created here, I no longer even know it's a model. My code has actually become less informative in doing so. So PSR0 gave us this nice way to do loading, but what it didn't think about was the implications necessarily that this would have on the way we named our classes and the way that we actually alias them inside of a file. So I'm going to talk about class aliasing. Not just class aliasing with use keyword, but class aliasing at runtime. Runtime equivalent. So right here, this basically does exactly the same thing as use does. We go ahead, we explode it, we get a name, we generate a namespace, we generate the class name, and then we call eval, which I know people don't like eval because it's injecting arbitrary code, but here it's controlled. And we're just going to go ahead and do that, and I think everybody will agree we've essentially implemented use. Not with using of namespaces, but using of individual classes themselves. So it's a partial use. Now, I have a class, framework model session, okay? When I go ahead and I use this, and I can say, okay, well, I screwed up the namespace here in the example, but basically this some vendor session model session, that was framework model session, we've created an alias. So it's accomplishing essentially the same thing that the use keyword does, but it's doing it at runtime instead of statically. So let's go a step further and say that we have a vendor class that the framework extends. So let me see. So we have these two classes now, right? We've got this base one that we already introduced. Now we've got our own where we've added some custom code. We've built in some extensibility that we're interested in. We can do resolution at runtime with autoloading and class aliases. Here's the idea. The idea is essentially that I can say, okay, let's register the autoloader, and then let's go ahead and say, let's build a stack. Let's say some vendor session, we can look there first. And so if I resolve a class inside of some vendor session, great. That's what I'll use. Unless I happen to find it in what came second, this framework. So in this particular case, what I'm actually trying to do here is make this possible. No use keyword anymore. Instead, I'd like to define an autoloader where I can get rid of the use keyword, and I can simply use the session by the name model session and let it resolve. In this particular case, if we can pull off this autoload that I'm talking about here, the model session will be framework model session. Now it's get parent class because ultimately it's basically just an extended version of that class. So I have to go get parent class because it generated a new version of the class. I'll go back real quick so you guys can see that. This piece right here, we're actually generating a child class, but it's a child class that's identical. But yeah, so that's what we're shooting for. So if we go ahead and we put framework model session, then we use that. If we don't have this class defined somewhere though, if we can't autoload that class, then it'll fall back to the some vendor version instead. So first off, we'll just make a stack of namespaces. And then we'll go ahead and we'll implement PSR0, but we'll tweak it a little bit because we're going to add some return statements. And we're going to put in that aliasing method that I've already talked about. And finally, we're going to improve our loader. In the past, this loader would have just been PSR0 class name, and that's it. And it would have assumed that that's found. But now what we're saying is, in the event that it's not PSR0, let's loop through our namespaces. And let's look and see if in any of our namespaces, in stack order, we happen to have that class in the namespace. And if we do, then we'll go ahead and we'll just alias that class. So if I've got that framework model session that I'm interested in, well, I'll alias that as model session. But if that's not there, I'll fall back and I'll check vendor session and find the model inside of that. So that's what we're shooting for here. And this implementation does work. So seamless substitution, really the cool part about this is now let's say I, as the application developer, so I've got this framework model, which extended some vendor's model of session. And now, I, as an application writer, say, nah, they did it all wrong. I don't like the way the framework did it. I really don't like the way the vendor did it. I want to completely redo it. Well, here we are. Now I just go ahead and I add this namespace of app model, and I say I'm going to define my session in it. And you'll notice that I can just extend the framework model session, which is something different than many of these autoloading stacks do. Many autoloading stacks say you take the class definition from here, or you take the class definition from there. What this is saying is we can still use all classes by fully qualified namespaces. And then we can simply import via class alias the kind of the one with the greatest precedence order in our stack. So to jump to the punchline, we simply add app to that autoload stack. So now it's got the greatest precedence. And now when we do this exact same command as we had earlier, it's now app model session. It's no longer framework model session. So we've essentially made it possible to seamlessly just drop in a new class that overrides everything that's already there, while still being able to use the entirety of the previous class. Oops. So the framework can extend the vendor classes. The application can extend the vendor classes or rewrite their own. We have no code changes necessary for the substitution. I just dropped a new file in my app area. Didn't touch the vendor class, didn't touch the framework class, didn't modify any configuration files. I just dropped a new file in the right place in the directory structure, and now that class takes over. So what we're doing here is we're giving the developer what they want when they want it. They can just go ahead and use it, or they can replace it. Or they can use it now, and later on they can say, well, I want this new stuff. They can go in, they can extend, they can replace. But they're not actually having to copy code from the old file, because we're not loading one file or another file. We're actually extending by full namespace, and then using by these alias namespaces. And so we stay out of their way otherwise. So an example of this is right here. If you guys pull up anything, if you pull up the slides later on, just go ahead and take a look. It's pretty much just what I went through on the slides. This actually shows it in action, so loading up a few namespaces. This is part of that toy that I had pulled up that's coming from a new framework we're working on, but it's super lightweight, really easy to use. You can drop it in and just get going. But yeah, so that's kind of the concept of using autoloads for seamless extensibility. Did I lose people, or did that make sense to people? Any questions on that section?
It makes sense to an extent, because you still can kind of get entangled in all your inheritance.
You can still get entangled in inheritance, that's right. And that is something that this piece is not getting rid of. What this piece is focusing on is trying to deal with freedom. Right? Unfortunately, giving a lot of freedom, it's also very easy still to entangle yourself.
Yeah.
The key to kind of minimizing that, I find, is more just on the level of don't code your framework to be everything relying on everything else. Code your framework to be everything as a distinct unit. Yeah. It's kind of more of a meta pattern in a way. That limit yourself on how deep you're willing to go with extensibility. But if you're using a vendor class, and then you've got a framework class that extends it, and then you've got a.
If you have several vendors, for instance, it would depend on the order how you define those aliases, right? So
it can, yes. Depends on it, but it also depends if there's namespace conflicts, right? They have to be defined in those same models and whatnot. So, yeah. But this can be a very useful pattern in some cases. So, yes.
I'm interested in your comments on the trade-off that somebody making here, which is failing early. So let's say you just wrote this session class, you wrote some other code that subtly depends on your variation of your session class versus the vendor session. But you forget to commit your session class to Git. Your autoloader is going to go back over the vendor's original version. Maybe the application mostly works, and you don't even notice that it breaks horribly in this other part that depends on your version of the class that doesn't.
I have a really sad answer to that, and that's unit tests. I believe in continuous. I'm a big fan of continuous integration. I would say, if it doesn't fail a test, it's not a failure. And if it does fail a test, well, then you know right from the start. So that's kind of my way of looking at that particular problem. But yeah, that sort of stuff is a problem. But it would be a problem no matter what. If you forgot to commit your config file that did your class map, you'd still have the same problem. So that's a problem we just have in general as soon as we're talking about extensibility. But you're right, it is a trade-off against just modifying the file directly. But modifying the file directly creates huge problems when you try to upgrade that file later on. Yes?
Yeah, I just want to make sure I didn't miss anything here. You're firing up the Lexer every single time you autoload a class? By calling me.
What?
You're firing up the Lexer every single time, over again, every single time you autoload a class?
There are ways to optimize all that. I mean, I'm not focusing on that here. But yes, at the moment with the example, that would be correct.
Okay, so this is just an example.
This is, yeah, these are toys in many ways. These are theories, these are ideas. You know, if I actually start burying, you know, if I start digging into all the code, we're just going to have these giant blocks of code. I'm trying to just keep things concise. So, yeah. Don't worry. Other questions? Okay.